Hi, so myself, Dr. A. Mohammed Ibrahim, working as an assistant professor in the Department of Triple E. So today we have a discussion about an AC microgrid using ETAP software. So we'll have a small simulation. So what is called AC microgrid, so how it functions actually. So generally we know about the microgrid. So what is called as a microgrid is called as a local power generation. So, in many industries, in educational institutions, and in shopping malls, so a small power generation has been installed. So, this power generation can be called as a microgrid. So, this grid is interconnected with an existing power grid. So, this is called as an generally called as a microgrid. So, the microgrid consists of the major components are in general it is called as in distributed energy resources. So the distributed energy resources may be of solar, wind, battery energy storage system, or it may be of an generator, electrical generator. We have either an AC source of generation or by means of a DC source of generation actually. The microgrid actually is often classified into, basically it is classified into three types. One is called as an AC microgrid, DC microgrid, and then hybrid microgrids. So hybrid consists of both AC and DC actually. So why we are going for microgrid is it is an reliable actually. It gives an reliable supply, and we can get an power. So excess power can be generated from the natural resources. We'll have the small AC microgrid system right now with the help of ETAP software. We'll design it, and we'll see how the parameters that we have to give for the power grid, for the transmission line or the cables are what we are using. Next, about the transformer input, and we'll check with then uh, wind turbine generators, DC generator or AC generators, about the uh, solar and the battery energy storage system. So we'll have then SLD. A grid is connected through a transformer to the bus, and we have the DERs. So we have plan to connect a generator, wind turbine generator. So we have static loads and then lumped loads. We have connecting the lumped load, and I'm going to connect the DC generations, such as solar energy. So we have a PVRA panel here. So then we can connect the battery storage system. We have batteries. Next, this is called as a DC to DC converter. and the system is called as an actually it is called as an AC grid. So we are going for an inverter here. So then these two buses are connected through a cable or on a transmission line. So I'm using the cable for the connection between these two buses. So this is generally called as an AC microgrid. So it will give input to the parameters. So the rating for the grid is about 11 kV. I assume it is for 11 kV grid. The short circuit MVA is about 100 MVA. So that's by R ratio is about 14. Then we are going for the transformer input. Transformer, the primary is about 11 kV and the secondary is about 415 volts. The MVA is about 100 MVA transformer. So we'll go with 50 MVA of transformer. The impedance will be the typical Z and X by R ratio. Next one will give the input to the cable here. So in cable, so we have to give the particular length and we'll go for the different types of cables are there. So based upon our requirement, so we can give the cable input. So I'm going to select the 50 Hertz metric copper cable of 0.5 kV. So the voltage, secondary voltage is about 415 volts. So I'm selecting it is on 500 volt and class percentage of class 100%. And it is 3-core polyvinyl chloride. So BS6141 non-magnetic cable and 2.5 square mm. So then click OK. Similarly for cable 1, so kindly give certain distance, it is of 10 meters. And the library, so go with the same 2.5 square mm. Click OK. So go with the wind turbine generator. So I have planning with 3 megawatt of generation with 415 volts. So the remaining things, it's enough. So next the generator. Rating is about 10 megawatt. The generator. So the load is about 2 megawatt of load consumption. Then we'll add another lumped load in the DC side. So the battery rating of the battery, so we can select from the library. We have different types of batteries. We select the plates as 7 to 50 capacity. So those things I'm giving okay. So DC converter, so it converts 10 kV 415 volts and output is also 415 volts. Okay, then we'll go with an inverter. What is about 10 voltage is about 415. Yes. Then we'll go with an PV array panel. So PV array panel is about 500 watts. And total power is about 100. The maximum power voltage is about 25. So voltage is this. Okay, and then PV array we have we have to take 425 volts. An inverter we have 10 415 input. Output is about 0.415 volts. Then click OK. Okay. Here we have another load, and load is of an assumed within 1 megawatt of load. So this is what about the inputs for the microgrid. So then I'm going to run the system to check the feasibility of the network. So go to the load flow study. Click OK. So hope that there won't be any error. Yes. Maximum number of iteration does not cover the maximum number of iterations. Yes. So we can see that. So spring color source it is lightly loaded, and this cable is often heavily loaded, and most of the power is taken from the wind turbine generator as from the generator. So it has an 99 percentage, 99.48 percentage of voltage, and 97.5 percentage of drop in voltage in these buses. So this is a small AC microgrid system of the network. So thank you all for the patient listening. Thank you.